Hi everyone, this is Charlie Rolsky. I'm the Director of Science North America for Plastic Oceans International. For this very special edition, quarantine edition of Breaking It Down, I'm going to be kind of addressing a lot of questions that you might have. I know that I've been sitting here quite often and much of the time I have more questions than answers when it comes to the coronavirus, COVID-19. So what I thought I'd do is I would check in with a good friend of mine, an incredible researcher at Arizona State University, specifically the Biodesign Institute. His name is Dr. Arvind Varsani. He studies viruses, and I'll let him tell you a little bit more about what he does and answer some really important questions when it comes to the coronavirus and COVID-19. Okay, so can you just go into a little bit of background about what you do and what your research kind of revolves around in terms of viruses?
Yeah, so basically my research group is kind of involved around understanding virus evolution and how viruses spread around the world, etc. So one of the main things that we've been studying is when new species or species are introduced into new environments, how do they become susceptible to viruses which are already in those habitats? And so this is kind of where we come in terms of studying evolution, how viruses emerge, etc.
Gotcha. Okay. So in kind of broad terms, how did this all happen? How did this all come to be to the point that we're all, most of us are inside and, waiting to see day by day what the numbers look like?
So a lot of this has to do with not knowing what is out there, number one, but also we've changed our lifestyles in a dramatic way, in the sense that with urbanization, we're in more closer conflict with wild animals, which we weren't, say, 1,000 years ago, as much as we are today. We live in high densities. We're interacting with wild animals a lot more closely. So the chances are of any pathogen that is in wild animals then spilling over into human populations it's significantly higher than it was 1,000 years ago or so. And with that, we're seeing this emergence patterns coming in. And here we are that a situation has broken out where it is highly likely, we're not 100% certain, but highly likely that a virus has emerged. This is a coronavirus that's emerged from a species that it's probably been infecting for long periods of time, maybe even, thousands and thousands of years without causing any symptoms in these animals. And now all of a sudden these animals are in close proximity to humans, and ultimately the viruses are then jumping out of them and sampling. So all you need in these kind of events is a one trigger point. So, it's statistics. So if you have 1,000 people in a room, chances are you'll find one person who's wearing a red shirt, if you're looking for someone who's wearing a red shirt. Whereas probability of finding that amongst two people is much lesser. And so it's a similar thing like that, is that something jumping into someone whose immune system might be compromised or anything is much higher. And then once it's in that individual, you basically push up the concentration of that virus or that pathogen, and then it spills out. So, you get a, direct impact as a result of that. And we live in very, very closed environments. We interact, we're social animals. And with that, if you think about 5 degrees of separation, someone who knows someone who knows someone. And through that same mechanism, the viruses, they don't care about who you are. They don't care about geopolitical boundaries. They're moving by contact and by a variety of different ways in that way. And so you think about how many people you come in contact with every day, even when I say contact, not touching them, but within a close proximity, we will in our daily lives be brushing indirectly shoulders with up to 100 people without even thinking twice about it. And I would pose to anyone, next time when we're back into a normal life setting where we're back to social interactions, just count within a meter of you how many people you see in a day's interaction. Normally, whatever you're doing, just see how many people you are within a meter. And I wouldn't be surprised you'll be in the order of 100 people if you're on campus. If you're at school, indirectly, you might meet the same person over and over again, but that should be counted as interactions. It doesn't have to be a unique interaction. It can be a re-interaction during a day. And you'd be surprised it'll be more than 100. Actually, 100 is well within what we would be doing within our own household, interacting with, our loved ones, our family. We would have more than 100 interactions in a day within a
Wow.
meter of each other.
Yeah, so I've never thought about it like that. That's interesting. And now I'm going to be much more aware the next time I'm out of that. So we've seen kind of similar. Oh, good.
So that kind of leads us to where we are today, is that, something spilt over through the network of communication that we have indirectly. It's a spread very, very rapidly.
Gotcha. Makes sense. And we have seen somewhat similar transitions in the past with things like SARS. How does something like this ultimately just go away from our population?
So this is where the challenge comes in, is where, you build a level of immunity so that the individuals who are infected will try and reduce the pathogen load within the system. And then ultimately it gets to a level where we can manage it. And, our immune systems are pretty good. And in the past, if you look at the first outbreak, the outbreak in 2001, the unique thing about that was that, it didn't spread too far. It did spread, but it wasn't as severe as what we are seeing today. And what ended up happening is that it seems to, through a variety of different preventive measures, those individuals who were infected, some of them passed away, but others who were actually exposed to it were able to produce antibodies, and those antibodies were able to clear it out. So it's almost like you're producing, our bodies are very good at, we have a very good immune system. And when our immune systems are really active, they can clear, there's a concept called neutralization. So basically they can actually bind to the virus and take them out of there. And so when your body is producing a lot of these, then you get to a state where, it's a negative effect, in the sense that anything the virus comes in contact with you, you're producing antibodies to it and taking it out of the system. So you're basically nullifying the effect, post-exposure.
Okay, that makes sense. And then what goes into kind of weighing the pros and cons when people are developing some sort of strategy for humans to then, try to keep themselves safe from something like this? Can you give any insight into that whole process?
I think you're breaking up there, so I might get you to repeat the question, please.
Sorry, yeah. So there's pros and cons in terms of people coming up with the strategy for humans to, make themselves less susceptible to something like this. Can you give any insight into what goes into weighing those pros and cons about how we should change our behaviors in regards to something like this?
Yeah. So a lot of it goes down to population structure. So within that, you need to weigh out what are the healthcare facilities you have in place. So if an X number of people were infected, were critically ill, then can the healthcare system handle those individuals, like hospitals? Are there enough hospital beds, etc.? But at the same time, you can also start looking at it from different points and say, if you can mitigate the spread of it, that means you can then contain it much better. And those individuals who are infected will develop immunity to it, and then obviously then the virus will not move from that community that far. So it's almost like saying, let's say there are little villages all around dotted on a piece of land, and one village is infected but another one isn't, but then there is another one 10 miles away that is infected. Then if that one village isolates itself and creates a boundary, a physical boundary, let's say, then nobody can leave there. So everyone in that village might be affected. Yes, it might have a consequence on them, but once they are cured of it, so they've developed antibodies and they've raised their immune systems, then whatever was there is then lost. So then they're fine, because then they've isolated themselves from spreading beyond that. And so that is kind of one of the things that's also, you keep hearing this thing about flattening the curve. And that is part of the reason, is that you want to reduce the number of incidences, the number of cases. So that means ultimately you'll have lesser people spreading it around, and you'll go through this phase. Those who are infected will all be quarantined or in this zone. where they'll then develop and come out of it. They will develop antibodies and come out of it immune to it in a way. And so this is one of the ways that, all these things get taken into consideration when planning these kind of strategies.
Okay, that makes sense. And the last question I had was, what is the future of viruses? Can this happen again? And do things like climate change weigh in terms of our susceptibility for this happening again?
Yeah, so, it is likely such events are going to happen again. It's not a once-off. They have been happening. The thing that we need to think about is a couple of things, that modern human society has changed its lifestyle. We've basically gone into altered environments, natural environments drastically. Okay, so with that, think about concepts. We're taking away land that was there for wild animals, converting into urban environments, into agricultural zones, etc. So that means the wild animals, their habitat is shrinking. So that means the animals within themselves are interacting with other wild animals. So between them, there is a higher spread of diseases, if any, which is likely. There is a lot. But those animals are also coming into urban environments because we've taken away their land. We've changed their land where they, used to forage in. And so that means the conflict between our domestic animals and the wild animals is higher. So with that, there is transmission of pathogens. And through that, also, we're coming into more contact with wild animals. So again, that transmission chain is there. So going back onto that, so we've altered land. But climate change also has a major impact, because with climate change, there is also a lot of habitats that are being lost. And with habitat loss, that means that animals are having to congregate into areas where they can survive. And with that, the population density of those animals is high in those areas. And again, with that, the spillover events are also high. And don't forget that when you push an animal into a very, very severe ecosystem or an environment, their immune systems are also down because they're stressed. And it's just the same way, when we're stressed, we're more prone to other pathogens because our immune systems are down. And as a result, these animals that are stressed, their immune systems are going to be down. And as a result, you'll see the seesaw effect of viruses moving between wild and domestic animals, and obviously interactions with humans from there on.
Well, that makes sense. That's super insightful. So that's all I had. I just wanted a brief kind of update on everything, but I really appreciate you taking the time to do this. Thank you. Thank you very much. And continue the amazing work there. And hopefully sooner than later, I'll see you around the building.
Cool. Thanks, Charlie. I really appreciate this.
All right. Take care.
Take care. Bye.
I want to thank you guys for watching the video. If you appreciate it, if you have suggestions, definitely leave us a comment, leave us a question. If you would like us to cover certain stories in the future, please email us at science@plasticoceans.org. Thanks for watching.